This is SpaceTime Series 26, Episode 38. Coming up on SpaceTime, another stellar stream adds more evidence to the Milky Way's history of cannibalism, the most accurate measurement yet for the W boson, and an Australian hypersonic scramjet to undergo US Defense Department tests. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have uncovered another stellar stream hiding deep in the Milky Way Galaxy. Stellar streams are created as the Milky Way Galaxy cannibalizes dwarf satellite galaxies, gravitationally ripping streams of gas and stars from the smaller galaxies as they get too close. The process, known as galactic cannibalism, is how galaxies grow by devouring smaller galaxies or merging into bigger ones. It's a messy process, with tidal tails of stars and gas on one or both sides of these galaxies during the encounters. And it's happening right now. Our Milky Way Galaxy is cannibalizing several smaller galaxies, including the Large and Small Magellanic Clouds, a pair of dwarf galaxies visible in the southern skies, as well as the Sagittarius dwarf galaxy, which is making what could be its third pass through the disk of the Milky Way on the other side of our galaxy, and losing more and more stars with each pass. In fact, the Sagittarius stream is the most direct evidence of this cosmic encounter. Interestingly, so far, astronomers have found far more streams in the Milky Way generated by globular clusters compared to those generated by dwarf galaxies. Globular clusters are tight balls of stars, often containing several thousand to several million stars, all gravitationally bound closely together. They're thought to have either been formed at the same time in the same molecular gas and dust cloud, or alternatively, they're the remnant inner cores of galaxies that have already been torn apart by the Milky Way. Recently, data from the European Space Agency's Gaia spacecraft has identified a new stellar stream from a dwarf galaxy in the Milky Way. The new discovery, reported in the astrophysical journal Letters, was achieved by astronomers using an algorithm called Stream Scanner, which is based on a match filter method. The study's lead author, Yang Yong from the Chinese Academy of Sciences, says the algorithm is designed to detect streams by combining proper motions of stars and photometry from Gaia. The authors have named the new stream the Yangtze. Yong says the Yangtze is now proven not to be an artificial signal based on interstellar excitation and the Gaia Data Release 3 scanning pattern. It was measured to have a width of about 1.9 degrees across the sky and a length of 27 degrees on the sky. It's located some 29,745.46 light-years from Earth. The average age of stars in the Yangtze stream is thought to be about 11 billion years, which could be close to the age of the Milky Way itself. So this is a very ancient artifact. The authors also tried to understand whether Yangtze was associated with other known streams and globular clusters in the Milky Way. They found that the Palomar 1 stream was near to the Yangtze in angular momentum and energy space, and the anticenter stream was almost on the same orbit as the Yangtze. So the dynamics and metallicity estimate suggested the Yangtze may be closely related to the Palomar 1 globular star cluster and the anticenter stream, which is thought to be the remains of a gravitational tidal tail caused by the Sagittarius dwarf galaxy's first passage through the disk of the Milky Way. Studying dwarf galaxy debris streams provide astronomers with key materials to reveal the galactic structure and evolution of the Milky Way, and so the Yangtze should be helpful in further studying the merger history of our own galaxy. This is SpaceTime. Still to come, the most accurate measurement yet of the W boson, and Australia's hypersonic scramjet to undergo US Defense Department trials. All that and more still to come on SpaceTime. Physicists at CERN, the European Organisation for Nuclear Research, have refined their understanding of the mass of the W boson, finding it to be some 80,360 megaelectron volts. In physics, an electron volt is a basic unit of particle energy. the amount of energy gained or lost by a single electron as it accelerates from rest through an electrical potential difference of 1 volt in a vacuum. It equates to about 1.602 by 10 to the minus 19 joule. The energy of visible light ranges from about 2 to 3 electron volts. And thanks to Albert Einstein's famous mass-energy equivalence equation, E equals mc squared, or energy equals mass times the speed of light squared, it's also a unit of mass in physics and astronomy, giving 5.6 times 10 to the 35 electron volts to the kilogram. The W boson is one of 30 fundamental particles that make up the standard model of particle physics, the foundation stone upon which our whole understanding of the universe is based. W boson is a gauge boson. It's a force particle, and it carries the weak nuclear force, which is responsible for the beta decay of particles and nuclei, a form of radioactivity, and which initiates the nuclear fusion reactions that power the Sun. The weak nuclear force is one of the 4 fundamental forces of nature. The others being the strong nuclear force, which is mediated by the Z boson and works inside the nucleus of atoms, where it keeps photons and neutrons together with each other. Then there's the electromagnetic force, which is moderated by the photon and transfers energy, such as electricity, light, and heat. And there's the gravitational force, which may simply be the effect of mass bending the fabric of space-time. Physicists refer to the yet-to-be-discovered graviton as the potential mediating particle for the gravitational force. The new, more precise measurement for the mass of the W boson was derived by a scientist with the ATLAS experiment, one of 4 major particle detectors around the Large Hadron Collider, the world's largest atom smasher, a 27-kilometre-long ring located 100 metres underground along the Franco-Swiss border near Geneva. The preliminary findings are based on a reanalysis of some 14 million W boson candidates produced in proton-proton collisions at the Large Hadron Collider. The new measurement concurs with and is more precise than all previous W mass measurements except one, the latest measurement from the CDF experiment at Fermilab's Tevatron accelerator. The W boson's discovery at CERN 40 years ago helped confirm the theory of the electro-weak interaction, which unifies electromagnetic and the weak nuclear forces. That theory is now a cornerstone of the standard model of particle physics. The CERN researchers who enabled that discovery were awarded the 1984 Nobel Prize in Physics. Since then, experiments at particle colliders at CERN and elsewhere have been measuring the W boson's mass with ever-increasing precision. See, in the standard model, the W boson's mass is closely related to the strength of the electro-weak interactions and the masses of the heaviest fundamental particles, including the Z boson, as well as the top quark and the Higgs boson. In this theory, the particle is constrained to weigh some 80,354 million electron volts with an uncertainty of just 7 megaelectron volts. Any deviation from the measured mass from the standard model prediction would be an indicator of new physics, possibly new particles or interactions. To be sensitive to such deviations, mass measurements need to be extremely precise. In 2017, ATLAS released its first measurement of the W boson's mass, which was determined using a sample of W bosons recorded at ATLAS in 2011 when the Large Hadron Collider was running at a collision energy of just 7 tera-electron volts. It's now doing double that. Back then, the W boson's mass turned out to be 80,370 megaelectron volts, with an uncertainty of 19 megaelectron volts. Now, at that time, this result represented the most precise W boson mass value ever obtained in a single experiment, and it was in good agreement with the standard model prediction and all previous experimental results, including those from experiments at the Large Electron Positron Collider, the Large Hadron Collider's predecessor at CERN. Then last year, the CDF collaboration at Fermilab announced an even more precise measurement based on an analysis of a full dataset collected by the Tevatron. That result measured the W boson at 80,434 megaelectron volts with an uncertainty of 9 megaelectron volts, which differs significantly from the standard model prediction and from other experimental results. And it was that which called for more measurements to try and identify the cause of the difference. Now, in this new study, Atlas reanalyzed the 2011 sample of W bosons, improving the precision of its previous measurement. The new W boson mass of 80,360 megaelectron-volts with an uncertainty of 16 megaelectron-volts is 10 megaelectron-volts lower than the previous Atlas result and 16% more precise. Importantly, this result is in agreement with the standard model. In addition, Atlas also verified the theoretical description of the W boson production process using dedicated Large Hadron Collider proton-proton runs. Due to an undetected neutrino in the particle's decay, the W mass measurement is among the most challenging precision measurements performed at Hadron Colliders. It requires extremely accurate calibration of the measured particle's energies and momenta, and a careful assessment and excellent control of the modelling uncertainties. Atlas Physics Coordinator Pamela Ferrari says further measurements of the W boson's mass are expected from Atlas, as well as CMS and the L8CB detectors on the Large Hadron Collider, the L8CB having already weighed the boson in the past.
W boson is a fundamental parameter of the standard model. And as such, if we measure something that slightly differs with respect to what the standard model predicts, this will be a hint of new physics. What we have done is that we have reanalyzed our data and we managed to reach a much better precision. So initially we had a 19 MeV precision and now we have a 16 MeV precision on the W mass. This actually accounts for a 16% improvement on this difficult quantity to measure. So every percent of improvement, it's really, really difficult to reach. The comparison with respect to previous measurements confirms us that our measurements are in agreement with the standard model. How did we obtain that? We obtained it by improving our analysis methods, so decreasing the systematic errors that we had on the measurement. Then we used a better knowledge of the modeling of the production process of the W and of the substructure of the proton. Of course, this is not the end of the story. We hope, and we will, use new data that haven't been analyzed to investigate this further. So this is still an open quest, and the future will tell us more.
That's Atlas Physics Coordinator Pamela Ferrari. And this is SpaceTime. Still to come, an Australian hypersonic scramjet to undergo US Defence Department testing. And later in the science report, a new study shows that both getting too much and too little sleep could increase your risk of getting sick. All that and more still to come on SpaceTime. The United States Department of Defense has selected the Australian Hypersonix Launch System for testing the next generation of hypersonic aircraft. Hypersonics was selected ahead of 63 other entrants by the Defence Innovations Unit to develop its Dart AE scramjet aircraft under the Hypersonic and High Cadence Airborne Testing Capabilities, or HICAT-1 program. The Australian design is capable of flying at well over 7 times the speed of sound. The speed of sound, or Mach 1, is 340 metres per second at sea level. This program is designed to develop long-range hypersonic aircraft, their communications, navigation, guidance and control systems, and all the technology needed to detect and track them. The mission calls for aircraft capable of operating above speeds of Mach 5 with a manoeuvrable and non-ballistic flight profile, and being able to fly for at least 3 minutes duration in near constant flight conditions, repeatable at short intervals. Now, Hypersonics claim their Dart AE can do all of that and do it above Mach 7, thereby far exceeding the HICAT-1 specifications. The Dart AE has a range of around 1,000 kilometres that equates to just 400 seconds of flight time, carrying a 10-kilogram modular payload. It's slated to undergo its first test launch next year. Australia has been leading world research into hypersonic scramjet engines for over a quarter of a century. That's one of the reasons why the United States wanted us in the AUKUS agreement. The University of Queensland Centre for Hypersonics, led by Dr. Alan Paul, were the first team in the world to successfully fly a scramjet engine, even beating NASA's X-43A. Paul and colleagues developed and flight tested their supersonic air-breathing scramjet engines under the HiShot program. HiShot used scramjets attached to the nose of Terry Orion Mark 70 sounding rockets, which were then launched from the Woomera Rocket Range in outback South Australia. The historic first successful scramjet test flight was back in July 2002, when a scramjet powered up and propelled itself in flight for several seconds. When the mission reached a speed of Mach 7.6 and an altitude of 314 kilometres attached to the sounding rocket, the scramjet vehicle was released, changing its course and trajectory and returning to the Earth. It then ignited its scramjet engine and undertook powered flight once back in the atmosphere. The whole experimental flight from launch to landing only took about 10 minutes, a small amount of time, but an event which changed history. The ultimate aim of the HiShot program is to develop a single-stage-to-orbit launch system. See, scramjets, or air-breathing supersonic combustion ramjets, have no moving parts, with the engine's design compressing incoming air and then injecting compressed liquid hydrogen propellant through a combustion chamber at supersonic speeds. As the air flows, it burns the hydrogen, giving off an exhaustive water vapour. The scramjet engine is lighter than conventional jet engines and a lot simpler. And by adding an oxidizer, once the air gets too thin, the scramjet can also operate in space, thereby attaining single stage to orbit. Now, if scramjets prove successful, they have the potential to considerably lower the costs of launching a satellite into orbit. The Hypersonics announcement follows news that New South Wales-based company QuickStep, together with the University of New South Wales and their HypeX project, have been selected by the Australian Department of Defence to work on new types of materials which would be needed for the next generation of hypersonic weapons and aircraft. Of course, rockets and missiles have been flying at hypersonic speeds ever since the start of the space age. But the key of what we're talking about here involves being able to maintain those speeds in the atmosphere, where friction can heat up surfaces to many thousands of degrees, and also to be sufficiently manoeuvrable in mid-air flight so as to avoid being intercepted or detected. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that either getting too much sleep or too little sleep could increase your risk of getting sick. The findings, reported in the journal Frontiers of Psychiatry, are based on surveys of some 1,848 people in Norway who were asked about their sleeping habits and whether they had recently had any infections or needed any antibiotics. Researchers say those who reported sleeping less than 6 hours a night were 27% more likely to report a recent infection, while those who reported sleeping more than 9 hours a night were 44% more likely to be sick. Researchers found that sleeping too little or having chronic insomnia was associated with higher antibiotic use. While this study can't prove that sleep duration is causing these infections, the authors say it still underlines how important sleep must be to keep your body healthy. A new study by the OECD has found that Sweden may well have been right by staying open during the COVID-19 pandemic. While many countries, including Australia, embraced crippling lockdowns, Sweden chose not to lock down its population, remaining open instead, and after 3 years, they've been vindicated. The new Organisation for Economic Cooperation and Development Analysis shows that Sweden ranked lowest in the world for overall cumulative excess deaths from 2020 to 2022, at just 6.8%. That compares to Australia at 18%, New Zealand at 15.5%, the United Kingdom at 24.5%, Canada at 29%, and the United States at 54.1%. Sweden was one of the few developed nations that opted against widespread lockdowns or outdoor masking, and even Swedish schools remained open during the pandemic. By comparison, in Australia, for example, Melbourne became the most locked-down city in the world, with police arresting pregnant women in their homes, bashing and dragging away people sitting in public parks, and even harassing people taking out the trash. In some states, police use drones to find people breaching COVID lockdown rules. Instead, Sweden opted for a voluntary approach to dealing with the pandemic spread. Over 6.8 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. The World Health Organization, however, estimates the true death toll to be somewhere around 16 million, with some 683 million confirmed cases globally. New research shows that human-modified landscapes are affecting the diets of Tasmanian devils. According to a study by the University of New South Wales, these marsupial scavengers have access to vastly different cuisines depending on the type of environment they're living in. The findings are published in the journal Science. Previous studies showed that most Tassie devils are individual specialists, feeding on the same food items consistently over time. But human impacts could be influencing whether they have access to their favourite foods. Researchers investigated the diets of devil populations by analysing chemical stamps called stable isotopes in whisker samples taken from Tasmanian devils in different environments. They found devils in human-impacted landscapes, including both cleared lands and revegetated native forests, tended to feed on the same sorts of food items, especially medium-sized mammals. While in more natural, undisturbed rainforest environments, devils ate a far broader range of prey and incorporated lots of smaller animals such as birds into their diets. Meanwhile, a separate study reported in the journals The Proceedings of the Royal Society B has found that introducing Tasmanian devils to open grasslands caused brush-tailed possums to disappear. Scientists used trail cams, GPS collars and spotlight data on Manor Island before and after the devils were introduced in 2012. And they found that between 2012 and 2016, possum populations declined across the island, dispersing almost completely from grasslands and drier forests with open country. But they say possum populations remain stable in forested habitats, which are not their preferred choice of home, but did provide better refuge from devils. A major security threat's been uncovered by Google, which affects people with some Android phones. With the details, we're joined by technology editor Alex Zaharov-Reutt from itwire.com.
Google is urging Android phone users to switch off Wi-Fi calling. Google's Project Zero team has uncovered a number of security flaws. They say that tests conducted by Project Zero confirmed that there are 4 vulnerabilities, just needing the victim's phone number, which allow an attacker to remotely compromise a phone at the baseband level with no user interaction and require only that the attacker know the victim's phone number. With limited additional research and development, they say they believe that skilled attackers would be able to quickly create an operational exploit to compromise affected devices silently and remotely. So there's various Samsung Galaxy phones. They say it's the S22, M33 range, the A71, A53, A33, A21. I mean, these are all relatively recent phones. There's a bunch of Vivo phones. There's the Google Pixel 6 and 6 Pro, Pixel 6a, 7 and 7 Pro, latest ones. They're saying any wearables that use the Exynos W920 chipset and any vehicle that use the Exynos Auto T5123 chipset. Now, apparently Samsung is aware of the issue and they're working on a fix. But Google says that users can simply turn off Wi-Fi calling. So you navigate to an open settings, you tap on connections, tap on Wi-Fi calling, make sure that's off. You can find Google's full report online. But, these sorts of vulnerabilities or zero-day hackable discoveries happen for Windows, for Apple, for Samsung, Android devices. I mean, it happens all the time. The trick is to keep up with the news, listen to this podcast and others, and when you see there's an alert, make sure you update.
And there are also fake Samsung SSDs out there you've got to keep an eye out for. Tell us about it.
Yeah, just like there are 2 terabyte USB sticks being sold for $20, which will corrupt after the first 32 gig is written. There are now fake Samsung 980 Pro SSDs on the market. Now, these aren't much cheaper than the real ones, but they're fake. Apparently, they're even managing to fool Samsung's own Magician software, which is used to manage the SSD. These drives obviously don't come with any official warranties. They probably are slower than what you would imagine they're supposed to be, and it just goes to show the craftiness of the bad guys. I mean, I remember a couple of decades ago that people were faking the Pentium chips in computers and showing you a slower chip than you were getting, or even a chip that was binned to be a chip that sold at a lower capacity, like a Core i3 or a Core i5 was being sold as a faster i7. So the fakes are out there. I only shop from reputable sources. Unfortunately, Amazon is not always a reputable source because there are lots of fakes online that are sold there. So buy it from a well-known store. Buy locally if you can. Support your local businesses rather than some online store. And, if you do end up with a fake from that store, at least you have some sort of recourse. But it is a worry that top brands like Samsung are being faked.
That's Alex Haravroit from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.